Hi everyone, hope you all are good. We are here for grade 9 math. So we're working on the book Maths Principles of Mathematics grade 9. We're working on chapter 6, that is properties of 2D figures, and the lessons we're going to cover from the chapter is reasoning about properties of polygons. Then we'll start the chapter measurement, and the lesson we're going to cover from the chapter is determining the optimum area and parameters. So let's just start with the lesson reasoning about properties of polygons. Okay, so here I'm on 7.5, reasoning about properties of polygons. The center of an object mass, the point at which it balances, also known as the center of gravity or centroid, right? By median, the line joining the midpoints of two opposite sides on a quadrilateral. Okay, the line that joins the two opposite sides, the midpoints of two opposite sides is quadrilateral, right? Okay, the centroid of a triangle is located at the intersection of the medians. Medians are lines from the each vertex of a triangle to the midpoint of the opposite side, right? The centroid of the quadrilateral is located at the intersection of its bimedians. Bimedians Bimedians are lines joining the midpoint of opposite sides. They are the diagonals of the parallelogram formed by the mid segments of the quadrilateral. Okay, let's just start with question number 3. Okay, so you have to complete the table. Square intersection of bimedians of diagonals and bimetric geometric properties are bisect each other, equal length intersection at right angle, split squares into four smaller congruent squares. Okay, so about the rhombus. Rhombus has the same side lengths. The centroid is then the cross section of the bimedians as the cross sections of the diagonals, right? So just like diagonals, the bimedians of a rhombus intersect at angle of 90 degree, they are perpendicular. The rhombus bimedians are the same length and divide the rhombus into four rhombuses that are of the same design and orientation as the original rhombus, only smaller dimensions, right? So that means the bimedians divide the rhombus into four rhombuses that are at the same design and orientation as the original rhombus, only smaller dimensions, right? Then for the rectangle, since the rectangle has the right angles, the centroid is then the cross section of the bimedians as the cross sections of the diagonals, right? So just like diagonals, the bimedians of a rectangle intersect at 90 degree. They are perpendicular. The rectangle bimedians divide the rectangle into four rectangles that are of the same design and orientation as the original rectangle, only smaller dimensions, right? That is for the rectangle. Okay, the centroid. Then third one is parallelogram. The centroid of a parallelogram is cross section of the bimedians as the cross sections of the diagonal, right? Then the bimedians of a parallelogram intersect and divide the parallelogram into four parallelograms that are of same design and orientation as the original parallelogram, only smaller dimensions, right? The centroid of a geometric kite, the next one is kite, is the cross section of the bimedians. The bimedians of a geometric kite intersect and divide the geometry kite into four irregular quadrilaterals, right? So when you divide the kite, it makes four irregular. So that means the centroid of an isosceles trapezoid is the cross section of the bimedians, right? The bimedians of an isosceles trapezoid intersect at angle of 90 degrees. They are perpendicular and divide the isosceles trapezoid into four trapezoids, two pairs of congruent trapezoids, right? That is for the isosceles trapezoid. Then non-isosceles trapezoid, the centroid of a non-isosceles trapezoid is the cross section of the bimedians. The bimedians of a non-isosceles trapezoid intersect and divide the non-isosceles trapezoid into four irregular quadrilaterals, right? The centroid of irregular quadrilaterals is the cross section of the bimedians, right? The bimedians of an irregular quadrilateral intersect and divide the irregular quadrilateral into four irregular quadrilaterals, right? Okay, let's just start with question number 4. Remy is building a Remy is building a triangular wooden shelving unit. The base measures 30 centimeter and the slant height measures 18 centimeter and 24 centimeter. He wants a horizontal shelf halfway between the base and the top. What length of wood should he cut for the shelf, right? Okay, so you have to, the base is 30. Okay, you are given the shape here. The base is 30, right? You have the slant heights 24 and 18. So he wants a horizontal shelf halfway between base and top. Here is the top, here is the base, that is the horizontal shelf halfway, right? What length of the wood he cut for the shelf? Okay, so the shelf is mid height of the shelving unit, right? This makes it a mid segment of the triangle. The opposite, the opposing side of the mid segment is the bottom of the shelf. We know that the mid segment of a triangle is half length of its opposite side. Opposite side is 30, right? The opposite side to this one is 30. So it would be L divided by 30 over 2 because the line is exactly halfway. So that would be 30 divided by 2 equals 15 centimeter. Okay, let's just start with question number 5. A trapezoid has parallel sides of length 51 and 144 centimeter. Its other sides measure 34 and 65 centimeter. Determine the length of the bimedians joining the two non-parallel sides. The distance between the parallel sides is 8 centimeter. How far is the bimedian from each side? Okay, the length of the bimedian connecting the two non-parallel sides is equal to the mean of the base and trapezoid, right? Okay, so the base is 144 plus 51, right? You have to calculate the mean. It would be L equals It would be L equals, you have to calculate their mean, 144 plus 51 over 2, right? It would be 195 over 2, that is 97.5. That means the length of the bimedian connecting the two non-parallel sides of trapezoid is 97.5, right? The B is the distance between two parallel sides is 8 centimeter. How far is the bimedian? You have to calculate the bimedian. So we know that the bimedian is the midpoint of the base and parallel to both of them. Thus, it's an equal distance away from both the bases, and then D equals, you have given 8. 8 over 2 equals 4, right? The distance of the bimedian from each side of the bases is 4 centimeter, right? Okay, let's just start with 7. Jerry is making a kite in the shape of an isosceles triangle. The sides are 41 centimeter and the other side is 18 centimeter. Jerry wants to attach a plastic support along the median meeting the midpoint of the shortest side, right? Determine the length of the plastic Jerry must cut from the support. Jerry wants to place another plastic support along the mid segment opposite of the 18 centimeter side. Determine the length of the plastic support, right? You can see that is an isosceles triangle. So it would be, determine the length of plastic Jerry. We have to apply the Pythagorean theorem, right? That would be c square equals a square plus b square, because it can make, the isosceles triangle can make two right triangles, right? It would be, it looks like this. So if you make a line, it makes two right angle triangles, this one and this one, right? That's why you can apply the um hy- that's why you can apply the Pythagorean theorem, right? Okay, let's just substitute the values. The two sides are 41 and 18, so it would be 41 square equals 9 square plus b square, right? You have to calculate the value of b, so it would be 1681 equals 81 plus b square. So b square is 1600. B equals 40 then, right? That means the length of the plastic that needs to be cut is 40 centimeter. Okay, for B, Jerry wants to place another plastic support along the mid segment opposite to 18 centimeter. Okay, the length is 18 centimeter, right? You can divide it by the 2 and it would be then 9. That means the length of the plastic that needs to be cut is 9 centimeter. Okay, question number 8 is, Sarva constructed a quadrilateral from an art project. She located its centroid by drawing the bimedians. Then she divided to cut the quadrilateral into two pieces along one bimedian. Explain how to determine the centroids for her new quadrilateral using only the remaining bimedians. So she has cut a quadrilateral along the bimedians, right? Then half of the bimedian remains as a bimedian of a new figure. So to find the centroid, we need to find another bimedian of a new figure, find the midpoints of the opposite sides and connect them. The intersection with the already existing bimedian is the centroid for the new figure, right? Okay, the next one is explain how diagonal properties help determine the centroid in different quadrilaterals. So the diagonals of quadrilaterals that are square, rectangle, rhombus, or parallelogram intersect at the same point, where the bimedians of the same quadrilateral intersects, and since the intersection of the bimedian is centroid of the bimedians, the intersection of the bimedians is centroid, then the intersection of the diagonals is also the centroid figure, right? Okay, so we are done with chapter 7. We're going to start with chapter 8. And chapter 8 is measurement. Let's just start with the chapter. Okay, here is 8.1 determining optimum area and perimeter. Let's just start with the lesson that is determining optimum area and perimeter. Okay, rectangles with the same perimeter can have different areas, and the rectangles with maximum area for a given perimeter is a square, right? Rectangles with different area can have the same perimeter, and the rectangles with a minimum parameter for a given area is a square. Collecting and plotting possible solution data helps to estimate optimal values. So a rectangle with a border on three sides has a maximum area and a minimum border length when the side without a border and its opposite side are twice the length of the other sides, right? Okay, let's just start with the practice questions. Each rectangle has a parameter of 64 units. Which one has the greatest area, right? You are given the rectangles and their parameters also. You have to calculate you have to see which one has the greatest area, right? So for the A part, you are given length time width, right? Length, you are given the length and you are given the width also. So you have to do for the area, you have to do length times width. So 30 times 2 is 60. Same here, 12 times 2 is 240. Then you have to do 16 times 16, that is 256, and 24 times 8 is 192, right? Okay, we'll start with question number 3. Determine the maximum area. Determine the maximum area of a rectangle with each parameter to one decimal place. Okay, you have to calculate the parameter, right? You are given, okay, you are given the parameter, you have to calculate the maximum area of the rectangle, right? So you are given parameter that is 100 centimeter for the first one. The parameter you are given is 100 centimeter. You have to calculate the maximum area, right? So to find the maximum area of a rectangle using parameter, we need to use the condition for a rectangle area to be maximum. This condition is that the width of a rectangle is twice its length, right? That means we can say the width of a rectangle is twice its length, right? So it would be A equals to B, or either B equals to over A. A B equals A over 2. Okay, we know that the parameter equals B to A plus 2B, and you are given the parameter that would be 100 equals 2A. Just replace the B with the value, it would be 2, and the value is A over 2. So 2 and 2 got cancelled out, so you are left with 100 equals to A plus A 3A. Divide both sides by 100, so it would be A equals 100 divided by 3, right? You have to calculate area. Area equals side times side, right? You have to do A times A over 2. That would be A square over 2. So the sides are, let's just put the value of A, it would be 100 and 100 over 100 over 3 and 100 over 6. So it would be 1 centimeter square, right? You have to calculate the, you are given the parameter that is 100 centimeter, and you have to calculate the area. So we know that the parameter would be double the length would be double the width, right? It would be A equals 2 over B, that means B equal to over A. That means it is 1111.1 centimeter, right? Okay, the next one is determine the minimum length of wood needed. B part. Determine the minimum length of a wood needed to build a rectangle frame for an art sketch of each area to one decimal place. Okay, the first one is 1 meter square. Okay, so you have to calculate the minimal border length of the rectangles, right? We use the same condition as the we did. We will use the formula for the area to find the length of A, and then use that length to find the minimum parameter. So let's just calculate 1 meter square. You are given 1 meter square is the length, right? We have to use the same condition, that would be 1 equals A over A times 2. That would be 1 equals A square divided by 2, right? So A square equals B and 2, sorry, where is B? That would be 2 and A equals square root 2, right? So now we can use the formula for the parameter, that is P equals 2 times A plus 2 times A over 2. 2 and 2 cancel out. So you are left with 2A plus A, that would be 3A. And the value of A is square root 2, that would be 3 square root 2. Okay, the next one is question number 5. An outdoor rectangular skating rink with an area of 126 meters square will be built with one of its side length next to the community center to enclose the ring. Three sides of fencings are needed. Create a table of values that compares width, length, and perimeter of the ring for previous width of fencing shown. So the area of a rectangle is the product of length times width, isn't it? So if the rectangle has a width of 1 centimeter, then the length of the rectangle is same as 126 meters, right? Since it is specified that the area is 126 square meter, right? So that means when width is 1, the length is 126 and the parameter is 128. When the width is 2, the parameter is 63, right? You have to divide it by the 2 and it would be 67. So when width is 3, you have to divide 126 by 3, that is 42, and it would be 48. Then when width is 4, the length is 31.5 and the parameter is 39.5. When width is 6, it would be, you have to divide it by 621 and here you have 33. When width is 9, it would be 14, length and parameter would be 32. When width is 12, the length is 10.5 and the parameter is 34.5. When the width is 14, it would be 9 and parameter would be 37. When the width is 21, it would be 6 and this one is 48. When width is 42, this one is 3 and parameter would be 87, right? Okay, use a scatter plot. Okay, you have to make a scatter plot of the values, right? Okay, the same piece of string was used to create three rectangles. Which one has the maximum area? Explain your thinking. So you have three of the rectangles, right? You have to see which one has the maximum area. That means you can see C is the square. Square has the highest area, maximum area. That means C must have the maximum area, right? Okay, let's just start with question number 9. Okay, what is the largest rectangle area that can be built with a 20-meter fencing in the corner of a building? Create a table of values showing possible parameters, width, lengths, and areas. Construct a scatter plot. Okay, you have to do the same question like same we did with question number, the one we did. You have to do the like question number 5, right? Okay, let's start with question number 10. Randy is building a rectangular fenced dog run beside his barn. He has 120 meters of fencing and plans to use the side of the barn as one side of the fenced area. What is the dimensions of a dog run that maximizes the area Randy can enclose? So, the fence is rectangular in shape and we need to calculate the maximum area, right? That means the parameter would be P equals 4a. So the parameter given is 120 meters, right? The parameter is given, that is 120, and we know that equals 4a. So it would be a equals 30, right? That means the fence is a square with a side length of 30 meter. And then the dimensions are 30 cross 30. Okay. The next one is question number 11. A farmer has $3,600 to spend on fencing for three adjoining rectangular pastures as shown. The pastures all have the same dimensions. A local constructing company charges 606.25 per meter for fencing. What is the largest area that the farmer can enclose? $3,600, right? Just divide $3,600 by 6.25. Let me just see. It is 576, right? 576 meter, right? In 300, the $3,600 fencing by the rate of 6.25 covers 576 meter, right? Okay, we need to have a square fence with two dividers in the middle. So we can see from the given picture, this means there are a total of six lengths of fence, right? So it will be 6a. You have to do 576 equals 6a. A equals 96. Also, when you have to calculate the area, just square 96. So a square equals 96 square. A square equals 9216, right? Okay, the next one is complete the and extend the mind map of rectangles. Okay, you can do the mind map on your own. Question number 13. A 60 centimeter length of rope is to be cut into two pieces of two from the parameter of two separate squares. The total area of the two squares is to be maximum. Calculate the dimensions of the squares to the nearest hundreds. Okay, so you have 60 centimeter, right? Okay, so you have to suppose the smallest side length of the small square, right? That would be 0.01. So you have to calculate the area of two squares. It would be 4 times 0.01, that is 0.04. So the length is 60 centimeter, right? Then the parameter is 60 minus 0.04, that would be 59.96. So you have to calculate the length of the remaining strip. So you have to divide 59.96 by 4. That equals 14.99 centimeter, right? Also, you have to calculate the total area. The total area would be A1 plus A2. You have to add both the areas, right? So you have to calculate the total area. A1 is 0.01 and A2 is 14.99. Just two calculations and you can calculate the value, right? So we are done with the lesson. So we were working on grade 9 math. We have started with the chapter properties of 2D figures, and the lesson we have covered from the chapter is reasoning about properties of polygons. Then we have started with chapter measurement, and the lesson we did is determine optimum area and parameter. So please, you can complete the questions I skipped. You have to try them on your own. So if you need more help with the questions, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. So if you have any question, you can please ask. Okay, that's all for today. See you in the next session. Bye, everyone.